and play. Look at that. All right. Now, the big thing. Yes.
My free space is decreasing.
Yeah, it's okay. Just leave it. There's not much we can do about it. All right. So today's topic is how to define a problem. We talked about what programs are, what hardware, what computers are, hardware, software, input, output processing. Now we're talking about how to define it, because as much as it's fun to get in and start programming, like I've seen some people program already, it's great. It's a lot of fun, but we need to sort of learn how to walk before we can run, or crawl before we can walk, or all that sort of stuff. We will get to programs like code soon, I promise you. We're having some problems with Eclipse, which I've just worked out how to solve today. Thank you to Sam. Yeah, it's sort of stalled the process a bit. So we'll get there. But today we're going to be looking at how to define what the problem is. Sounds pretty silly. You have to work out what the problem is. We have to do that, and have to do it in a way that conforms to good programming practice as well. Like I think I mentioned in the first lesson, you might be able to code. That's great. We're going to learn how to code properly. That's the key. And does anyone know who these two people are? Einstein, yes. Well, they're not both Einstein. One of them's Einstein. There's a slight difference between the two. I don't know if you've noticed.
One's in colour.
One's in colour. That's right. Einstein, and anyone know who the other guy is? Neil deGrasse Tyson. He's like an astrophysicist or something like that, but he's a very, very, very good speaker. If you look up on YouTube for him, he's a great public, and he's really, really scientific, and yeah, he's really good at explaining things. He tried to explain. I was listening to a podcast. He was trying to explain how big the universe is, and his description was really, really good. But anyway, he's a really good speaker. I suggest you do it, and he doesn't look like that the whole time. But yeah, he's also the guy behind the meme. We got a badass over here. Everyone's going, whoa. That's a sketch of him. Anyway, so today we're going to talk about IPO tables, how to problem solve, and flowcharts. So that's what we're covering today. Okay, first of all, you've got to be able to plan your solution. That's what we want. You've got a problem. We looked at a problem last week about the 60 or above, satisfactory, unsatisfactory. You've got to look at how, or you've got to think about how you're going to break that down into a solution. And that's what programming is all about. At least the first stages of programming is working out how to plan it, which is why we're looking at flowcharts first, looking at the logic. So you're going to look at the sequence of events. So logic, you've got to do walkthrough, that's testing. And yeah, we're talking about flowcharts, pseudocode, and NS diagrams, but we're going to concentrate on flowcharts. All right, so here are some questions you internally think yourself when you're trying to solve a problem. Are there any key points? Are there, what do the end users want? Now, some of the early problems we're going to be looking at, end users aren't going to be a huge part of it because they're more academic exercises like the 60 or above, things like that. But programming is all about what the end user wants. Okay, particularly when you get to the assignments, I'm going to specify what the output should be, trying to act like I'm the end user. So this is what it should look like. And if you don't conform to that, you won't get as many marks as if you do. Okay, because programming is really all about what the user wants. Not about what the programmer wants, not about what your boss wants, not what I want as your teacher. It's what about the end user wants. Now I have to try and act like I'm a teacher and the end users, but it's about what the end user wants. Okay, and any data that needs to be stored along the way. So thinking about our exercise problem, the name, score, and prac result, that's 3 pieces of data that you have to store. During the life of the program, you might not have to store on the hard disk, it might be in memory, but you have to store those 3 pieces of data, name, score, and prac result, before you can do something else with them. So that's what you've got to look for, what you need to store in memory or on the hard disk. Okay, first of all, read the problem carefully. I cannot tell you over the number of years I've taught this, when students get a problem, they answer the problem they think the problem asked. They read like the key points and start answering that, that's great, but they don't actually answer the whole problem. Sometimes only half of it they actually answer. So you've got to read the problem and you read through the problem multiple times. Again, the problems we're going to be looking at initially, probably not so difficult in terms for this sort of thing. But when you get into, again, the assignments, you're going to have to read through the assignments multiple times. Don't just read it once and go, oh yeah, I know what I'm doing, and then do it. You've got to keep reading it. Refresh your memory about what's actually asked. And again, it should be what the client or the end user wanted. I'll let you read that one. It's very exciting. I found this on the weekend, and I thought, no, I've got to put this in a presentation.
Pretty recent.
Yeah, it was only like within the last week. So you all know who that is, yes? Star Wars. Come on. His first name is Harrison. What do you think his surname's going to be? Ford. There we go. Harrison Ford. Come on. There's at least one smile in the room. That's okay. But flowcharts. This is what we're going to be working in. So this is an example of a very, very, very quick flowchart. I don't know why that's there. That's a slide that shouldn't be there. All right, Raptor demo. We've already sort of had a quick look at Raptor, so I don't want to spend too much more on that. I'm not going to switch to Raptor now because, yeah, it was more just, this was writing it assuming that Raptor was there. I would now tell you to open it and do what I just did before, so don't worry about that. Again, I should have retweaked my presentation. All right, so this is exactly the same problem, even with my typo in there. Exactly the same problem as last week. Write a program, the raster uses their name, prac result, and the mark, and the parser, blah, 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 blah. So that's what we're going to be looking at in Raptor very, very, very quickly today. So here's an example of a flowchart. Wow. Do you guys know either of those two songs?
I do.
Do? Yeah? Wow, it's a tough crowd. I try and find funny pictures to put in here, and I just get blank stares back at me. I'm just going to randomly put pictures of me in there and just... Anyway.
We don't want to interrupt the presentation.
You don't want to interrupt? Okay, fair enough. All right, so one of the big things about problems is break it up into smaller manageable parts. Like again, the stuff we do at the start, probably not so difficult to break it up, but when you get bigger problems, you will need to break it up into smaller parts and keep breaking it down into something. So a quick example of a planning, not so much a flowchart, but it's more a pseudocode, I suppose, just writing down the steps involved, is hopefully you've all done some cooking before, whether it's just making a bit of toast or, you know, making a cake or something like that. This is sort of the equivalent of input, processing, and output. So talk us about planning and what you need to do to get to the output. This is what this is an example, a recipe of input, processing, output. So you've got the ingredients like the input. You need all those things to actually get the process going. The steps on how to do it are the actual processing. What you need, you've got all the inputs you need to do something, and the output is this. Raspberry cheesecake. So yeah, which, by the way, just out of interest, apart from the raspberries, a baked cheesecake is one of my favourite desserts, even though I'm both lactose and gluten intolerant. But it's worth it. So, you know, anyway. So that's into processing output. We're going to be focusing, the planning, what we're doing today is mostly focusing on this processing part. That's what we're working out. In theory, we've already worked out our inputs. We've already worked out how the output's supposed to be. We want to do the processing. And so that's using flowcharts. And in Raptor, there are these 7 symbols that we use. Now, I should also point out, especially if you're doing any research on the web, or in books, or you know those things with paper that put together, there's no standard for flowcharts at all. Like the symbols, they can be completely different depending on who wrote it. So like the beginning and end in this one is a circle. In some books or some websites, it might be a square, it might be a diamond. You know, there's no standard in there whatsoever. I've used these ones just simply because that's what Raptor, I've taken those screenshots from Raptor. So yeah, just be aware that you might have to, if you're looking up some other resource, you might have to try and translate what that flowchart's trying to do compared to what you're expecting. So anyway, they're the 7 ones. We've got the beginning and end. We've got the process or assignment statements, input, outputs, function call, selection, and the loop. And the loop looks suspiciously like a selection with a begin and end in it, and that's by design. Okay, so the selection and the loop are very similar. But yeah, talk about that. So yeah, what have I written there? I can't read this. Oh yeah, we get an exercise. All right, what I'm going to get you to do. You can do it on paper. Wrapped is probably not the best for this one, but I want you to. I can go get some paper if you need it, but if you've got a book, you can do it in pairs. I don't really mind, but I want you to think about how you would order food at a restaurant, and the restaurant serves burgers in quotation marks with chips and drinks. So I want you to write a flowchart for someone walking up to the desk and ordering food. Yes.
Can we use Word or something similar?
Yeah, if you want to use Word, that's fine. I don't really mind. You can do it in Raptor if you really want, although you won't be able to run it. But if you do it in pairs. But I want you to think about the process of you going up to the what are they called? People you order from in a restaurant.
Are you already in the restaurant?
Good question. It is a good question, and I'll tell you why in a second. But yeah, think about the process of you going up to order your food at a place that may or may not start with the letter M, that serves burgers and other food. I didn't say that.
I said.
I could have been talking about KFC or Kingsley's or Mo Portos. I don't know. So Mop Portos. Anyway, so think about that. Start writing it down a few steps. If there's some decisions in there, what the input to that process is, what the output of that process is. And so the big question is, where do you start? Josh said, are you already in the shop or in the restaurant? That's a very good question. For this exercise, I don't really mind. Let's say we're in the shop already. And let's say it's from the customer's point of view. Customer's point of view. Because it could be from the restaurant's point of view or the employee's point of view. But we want to say from the customer's point of view. So I'll give you 5 minutes to work that out. You can do it in Raptor, you can do it in Word. I'm not really that fast. You can do it on paper. And you can do it in pairs. You can do it together or the 3 of you or something like that. So if you work on that for 5 minutes, and we'll look at someone's answer after that. Any questions? Sorry? Okay. All right, so what's the problems here? Because this is something that you can actually get into the habit of doing something. So, getting started. Yeah, fair enough. No, that's good. Well, when you walk up to the desk in Macca's, let's say it's Macca's, I'm not advocating any fast food restaurant or any restaurant at all. I should point that out. But let's say we walk up to Macca's. Okay, what's the first thing you're going to do? What's the first thing that happens? Sorry. Sorry? No, you're inside the shop. You see the person who you order from is standing there. What's the first thing you do? Is that the first thing that happens? Do you just walk up to the desk and say, Big Mac? No? What happens? What happens?
Hey.
So think about, do they call you first? Do they say, can I help you first? Do they say, what would you like? Is there something that they do to you first to indicate for you to order your food? Yeah? So that would be the first step. They say, the first step would be like wait for instruction or something like that. It doesn't matter exactly what's written, but it's the first step is them acknowledging it's your turn. Then the next step is your input, or sorry, your output, I suppose. The process would be to order.
See food.
Right.
Okay? So start thinking about those sort of steps. Like this is stuff we do without thinking all the time in real life. Programming is about writing stuff down and organising it and being explicit with our steps so the computer can process it. Remember, these things are very dumb. So you're going to write down step by step what's going to happen. Yes, I agree. But also it makes it, that's right, they're so fast because they can only execute a certain number of statements. They've only got a certain number of things they can do. Whereas we can do thousands of things at once. Well, we're powerful until we get stabbed, you know. So another few minutes to work that out. Don't worry too much about the formatting, the structure of your code or anything like that. Just get the basic process down. That's what I'm interested in. And think about it from your perspective as the customer of this shop.
Are we doing like step by step, like walk up to the counter, wait, ask for food, wait, receive change, put it in bag.
Count change, complain.
Yeah, yeah.
Give tip, turn around,
Punch him in the face.
walk around, find the spot,
Say
sit down
hi.
in the spot.
This one is this exercise when I do is open. You can take it to whatever level of detail you want.
Okay.
I'm not that fast. So yeah. I should point out as well, there's no right or wrong answer for this. What it is an exercise to be aimedly retentive about the process of ordering food at this magical restaurant that serves magical food that apparently is actually food.
You?
Does anyone work in one of these magical restaurants?
I work with
Used to.
Michelle's
Yeah.
patisserie?
I
Used to. Okay. I do like. Of course, I'm not. I like how some of these places are called restaurants when you know it's fast food, but yeah, it's a restaurant. So
In Greece, you can get beer and salad from McDonald's.
in Europe, you can get beer from almost anywhere.
You know they look at
And you can smoke eggs.
No, they're cutting down on that one, but yeah,
Greece might be the exception.
yeah, maybe Greece is different. Yeah, I'm not
Well,
sure.
just on the radio, they were looking at the statistics and the price of healthy food is up here and the price of like unhealthy food is
Yeah.
down here.
That's why you get Macca's instead of going by somewhere or salad.
Yeah, because it's you know it's
Process.
cheaper, like from you know what's it called, economies of scale, because Macca's is so huge, so they're buying more meat, but they've got so much buying power, so it's not costing them as much for the same amount for equivalent amount. Yeah, and then they bulk it out with other stuff, and it turns into a Big Mac. Plus, they do it all centrally and ship it out. So, yeah. Because I was driving past Macca's this morning on the way to work, and there was a big truck out the front that said, you know, what was it? Can't remember. It was talking about lettuce. A picture of a lettuce on the side of this truck, and it said, "Washed twice, delivered daily." So, like, they don't even get the lettuce delivered raw to Macca's. It's all processed centrally and then shipped out, so it's just in big bags.
I'm
So
glad
it's-
they don't
it's-
try to say it's fresh though.
Well, no, but yeah, and
Well,
You know,
that
KFC
means it hasn't been fixed.
yeah, doesn't mean it's you know edible.
It
It's just
could
fresh.
be 2 years old and it still couldn't have been frozen.
It's washed twice, don't worry.
It's washed twice. Yeah. Why do you need to wash it twice? That's the other thing that I was reading. It's saying what is about this lettuce that you have to wash it twice?
The first one's to get off the dirt, the second one's to get off the people.
Wouldn't it be quicker, cheaper, and easier to wash the people? Or put gloves on? I was just disturbed by the fact it's washed twice. Why is it washed twice? The other thing I liked about Macca's, about 10, probably 15 years ago, I can't remember exactly when, they had this big marketing campaign. It was like for their breakfast menu. And they said, you know, egg and bacon muffins now with real bacon. So
Yeah.
what was I eating before?
I remember that.
What was and they're saying they're really proud of the fact they're being, you know, we're going to serve real bacon now. It's like, what the hell was it last week? All right, okay, just a few more minutes. As I said, there's no right or wrong answer.
Okay, first food.
Sorry, which one's that?
That's like the, yeah.
Oh wait,
No. Oh.
Max and
No, I didn't see that one. I don't watch ads. They annoy me.
why can't we have Max with like
Hmm.
normal people?
I'm sure.
I'm not-
All right.
These Max is so annoying.
So another, let's say, minute, and I should make sure I edit out this video of all my ranting about McDonald's because it's, if I'm going to put it up on Facebook, if I'm going to put it up on YouTube and it's going to be public, that could be a problem. The school could get in trouble.
I looked
So
at
if occasionally there's just, watch the video and then occasionally just beep, that's because I'm ranting that
you could
and
just chop it out and maybe just.
I'll just put this up for like 10 seconds and then
We can pause it if we want.
I probably can.
You're gonna say something so you can cut back into it so it seems like it's never missing.
Yeah, that's it. I'll just put up put a blank picture that just says, you know, students working ... or something like that. And
You've been using line one plus video anyways.
yeah, I'll probably read about Mac and nothing too. So. All right, so finish up what you got. I'm not going to sort of ask for details about the answers because it was more about the process of answering it. So, so what's the first thing that you do when you're inside Macca's or KFC or or Porto's or whatever? What's the first thing you have to do when you're standing there looking at the menu and the person's there?
Decide.
Decide?
Until you're first in line.
Sorry?
Wait until you're first in line.
Wait until you're next in line. Absolutely. Yeah. So you're gonna wait. What's the next thing?
Request food.
Request food. Yeah. Now the first thing you said, Zach, was you got to decide what you want. That's fair enough. Does that happen before or after you wait till you're first in line?
It can happen either way. I could decide that I want a burger, so I go down to McDonald's, or I could get there, look in the line, look at the menu, and say, "Hey, I want a burger."
So that's still before you get to first in line. Because trust me, you don't want to be the person in front of me that's saying, "Oh, it's my turn now. I've got no idea what I want." If you don't know, anyway. Sorry, I go on these rants when I can. So anyway, yeah, you got to decide what you want. You go to the front and you say, "What's the next thing?" You get to the front of the queue.
Say hello.
You say hello. If you want to be pleasant to, yeah, sure. You say hello. What's the next thing?
Order.
You order. What do you order?
You order burger, chips, and drink.
Okay, that's cool. So you order. But up until this point, the employee has done nothing. According to our process so far, the employee has done nothing.
They'll probably ask you what you want.
But they probably ask you what you want. Yeah, absolutely. So you get to the front, you get called up. They say, "Can I help you?" Or next, or you. They point at you, and then you say, "I would like a whatever. Big heart attack, please."
Oh, they're so bad, but they're so good.
What is it? The KFC was a double down. They had no bread on it. It was 2 breast fillets with something in between. Like that was the burger. It was chicken as the burger. It was just heart attack on a plate. Anyway, no, but they say, "What would you like?" And you say, "I would like this." Okay, so you've ordered. What happens next?
You pay.
You wait for what?
Good question.
What do you wait for?
Then they stop playing ice hockey.
Sorry?
Don't worry.
What do you wait for? You've ordered. You say, "I want a Big Mac."
Wait for the food.
Until you
Wait for the food to be cooked. Absolutely. So you wait for that.
You wait until they address with you. Do you want fries with that?
No,
Do they ask that anymore? I always order meals anymore, so I don't know if
They ask if you want Coke or like,
Oh, they also ask
Oh,
you
yeah,
would you
yeah,
like
yeah.
to upgrade that to
Yeah, true,
launch.
true.
I don't want to give 50 cents to
Or
charity.
do you want anything else today?
Okay, yeah, so let's say you complete your order, because you could go into the nth degree for this flowchart, but let's skip over because we've got limited time. So, okay, you wait for your food, and then what happens? What's the next step? You've waited.
You receive your food.
You received your food. Is that you stand there and they just throw it at you?
Sometimes.
Something. They call the number. That's a new thing they started down here, which I only found out the other day when I took the kids there. They give you a number now, like, and you wait for your number to be called, and then you go up, and then you receive your food. So you can just say wait and receive food, but there is actually more and more steps involved than just waiting to receive your food and then receive it.
Depends which restaurant though.
Depends which restaurant, yeah, true. But yeah, what this exercise was supposed to be for was not, how to order food at Macca's, because we all know how to do that. It was more breaking it down into more and more steps. I do have a much more fun exercise on this exact same thing. And I was hoping to do that today, except we only had an hour, and the exercise I've got takes an hour at least. Preferably I'd like more. So what we'll do is, on Thursday, we'll do that exercise. And that actually means, just wait for it, it means going outside. I know, it's in the sunlight, hopefully it's sunny, and we'll do it outside, and we'll do this exercise. And I should point out, if any of your friends have Line 5 free on Thursday, tell them to come down because they'll laugh at you. It's a very fun exercise. Well, at least for me, because I get to laugh at you guys too. So,
It's not to tell them that.
no, it's okay. We'll record it too and put it up on YouTube. Actually, I should. I haven't done it before. I will put it up there. It's a fun exercise for me. But we'll do that on Thursday because we need the time to do it. So,
you have to do it as well.
no, because I'm overseeing. I've been doing this exercise for 5 years and not once.
We can just get like a stationary camera. It's all good.
It's all good? Yeah, but no, I still have to oversee the exercise, not the video. Anyway,
You can oversee while participating.
this is true. I could do that, but that's not going to happen. All right, anyway. So, again, this process or this exercise was not to write down the exact order of steps to order food at Macca's. It was trying to break the problem up into smaller steps. And that's what programming is, breaking a problem up into smaller steps, even if that smaller step is wait. Sometimes you have to write that in programming. You have to wait for a certain amount of time. One thing about wait, and I saw a few flowcharts that had this. A couple of people just had wait. That's fantastic for at the moment. But when you wait in a program, that's actually a loop. You can't just say wait, because the computer doesn't understand that process. It doesn't understand it. You have to write wait for, like it might be wait for 10 seconds, but you've got to have a loop in there saying, is it 10 seconds yet? Is it 10 seconds yet? Is it 10 seconds yet? No, yes. And then you jump out. So you've got to put a loop in there for a wait. Again, like you're not wrong for just putting a step wait in there. I'm just pointing out that the computer doesn't understand a wait command. It is actually a loop. So anyway. And that's just there for poops and giggles. Anyone know who that is? I've really got to change my references if people don't know who Harrison Ford is, who Malcolm Reynolds is, who this guy is.
That's a guy.
Yeah. The IT crowd, yeah. Yeah. That's Moss in the background, Jen. And I've forgotten his name too.
I only know the fuzzy hair guy from that Neighborhood Watch movie.
Yes, that was very amusing. I watched that just.
That's much weirder than the book.
Yeah, I think it's just called The Watch, isn't it? Yeah.
Yeah.
I watched it. If you haven't seen it, it's a very strange movie. It starts off quite normal, and then about halfway through, probably, it just goes a bit weird. But it's a very good movie.
It's directed from one of the people from the Lonely Island.
Yes, yeah, which is
That's probably why it's so weird.
yeah, it is, yeah, and they're in it at one point. I don't want to give away, and I definitely don't want to say it while I'm on video, but they're in it at one point. But yeah, anyway.
So we made him lose his train of thought.
Yeah.
This video is so off track.
Anyway, so we've done our logic of our ordering at Macca's or some restaurant. Big thing is, and this is why I'm pulling it all the way back to flowcharts, is do not try to code without doing the logic first. Now, when you get more experience, you can, but when you start designing more complex systems, you do need to plan out in some way. You need to think about it. You might be able to do the logic in your head But when you're looking at massive, massive problems and more complex problems, you do need to do flowcharts first. Particularly for assignments, I will be requiring you to do flowcharts. So to prove to me that you've done the logic first, that your program works before you start coding. Because, yeah. Anyway, so as I said, you can take your flowchart, the logic of the code, and code into as many languages as you want. Java, Python, C++, whatever, because you've got the logic down, and that's the important thing. Algorithm is keyword. That's what this slide's for. Algorithm is something that pops up all the time in programming. The flowchart that you've drawn up for your ordering at Macca's, that's the algorithm. That's the term that we use, algorithm for ordering at Macca's. Okay, so I might ask you to write an algorithm. That means flowchart. Okay, so just some keywords. IPO charts, input, processing, output. Basically, it's another documentation step on, documenting your program. And so this is the thing that they actually do in real life when you do software development. In some environments, you do this IPO chart because the thing is in development jobs, the person who designs the code might not be the person who codes it. Because you might have someone who's really good at designing things and designing how different systems interact with each other and all that sort of stuff. But you might, almost running out of time, they might not be coding it because they might not be an expert in the language. So you need to document a lot of things. This is what an IPO chart looks like. It's literally a table that has the left-hand side is input, the right-hand side is the output, and the middle is processing. So this is not just a program, this could be a sub-program or a particular section. And this is what it might look like. And whatever goes in the middle, that could be your flowchart, or it could be pseudocode or something like that, or it could just be step-by-step written down, things like that. But this is the sort of thing. So once you've got the flowchart done, you can just paste that into your IPO chart and things like that. I'll put up a copy of, or a blank template up on Google Drive, so you can use that for any exercises or assignments and things like that. By the way, this is not a good flowchart for making coffee because, as you know, coffee with with either milk and or sugar is bastardized version of coffee. If you're going to drink coffee, you have it straight. Maybe with water, but it's coffee, not milk or sugar. So I'm sorry. I'm particular about my coffee. Yes, Josh?
There should be a cup in the input.
Straight in your mouth. We need cups.
Josh is on my list. If you want to be soft and drink coffee out of a mug, sure. If you want to pour it straight in your mouth, no, that's how real men do it. I just do it here because it freaks out other staff members if I pour the boiling jug into my mouth.
It's no kettle either. So
Sorry?
it's no kettle.
You grind it from your sweat.
Oh, in the input, yeah, I suppose that's fair enough. I did go like a camping trip with some guy who was feeling a bit tired, or he's trying to show off, I don't know. But he decided to eat instant coffee just out of the tin. Except he didn't eat it with or he did it with one spoon and then just went, yeah, it didn't really work. And he got dared and he stupidly did it. He just got the tin and just... He had to just drink water because his mouth was so dry. Anyway, so that's just an example. Not how to make coffee, but the IPO chart. So, yeah. Quick summary. Make sure you plan before you code. And planning, if you do the logic, it will save you so much time in the future. Something I wanted to do very quickly. Something I wanted to do if we had the time. So we might do this tomorrow, actually. We've got a short 45-minute lesson tomorrow. So we might do this exercise tomorrow. Is write a program to work out the surface area of one side of the cube, surface area of the entire cube, and its volume, and then output it to the screen. And Justin Bieber, just because.
He's going to try and get there.
Yeah, that's Justin Bieber in the UK, I think, when he was... and I think his lawyers actually said, I want that picture off the internet. Yeah, right.
Did you know there's over 200,000 signatures on an online petition to get him to 40 pounds a can?
Yeah,
Amazing.
I'm sure, yeah.
It's a legal petition, so that's
Yeah, but, you know, so he's a tool, possibly, in theory, allegedly a tool. But, you know, he's not the only one. You know, there's always been not many people wearing, you know, clothes like that. He's been a bit photoshopped, but, you know, whatever. Anyway, I just like that picture. All right. At my home, I've just got Justin Bieber posters everywhere. I'm a fan. All right. Any questions? Do I need to keep that? No, that's okay. You can keep it. It's okay. No, you don't have to.